I'm going to tell you a story about the Spring Component Model. And we're actually going to touch a few things that coincidentally appeared in the keynote in one form or the other. But with a different storyline, I hope with a more coherent explanation of why things are the way they are. The nature of puzzlers is that they wanna kind of show you where things can go wrong. I'm on a different mission here. I'm going to show you the way the component model has been designed. I'm going to explain, at least for certain key elements in the component model. I'm going to explain why they are designed that way, how things are supposed to work, and how you can fine-tune your use of certain component model features in Spring. In the given time frame, of course, this can only be a personal selection of features that I find important, nuances that I find important, design decisions that I find important. So it's a personal selection, a subjective selection of highlights, you could say. From the perspective of this talk, we are basically going to embark on a journey through the component model, reviewing it source code by source code, right? Kind of pieces of source code that indicate certain features in the component model. So this presentation consists of source code only. It does have slides, it's not a live demo, but we are going to do a design review, just staring at source code, basically. I hope that's to your liking. So let me quickly check. Who's actively working at developing with Spring, against Spring, Spring-based applications? All right, inverse question. Who's not actively working with Spring right now? Anyone not having had much to do with Spring at all? So anyone new to Spring? That's all right. I mean, the storyline is going to work, I hope, without much Spring background as well. Whatever. All right. For the three part, we're going to talk about Spring Framework as it is today. So we're going to talk about the component model in its 2016 state of affairs, state of the art. This is not a what's new in 4.3, but there are going to be some 4.3 specific changes sneaking into the picture, and I'm going to mention at least that they are new in 4.3 occasionally. The point of the storyline here is, it's not actually that important when things have been introduced. The programming model, the configuration model, is the way it is now in 2016. It doesn't actually matter that much whether a particular feature or refinement has been introduced in 4.1 or 4.2 or is even older than that. That shouldn't matter as much. Basically, take it as what it is right now, the modern day Spring component model and all of its nuances. All right, I will start with the basics, but I'll keep it brief, and I'm going to spin it in a certain way. The heart of the component model is this notion of taking a Java class, basically a regular Java language class, and turning it into a Spring component, into a Spring Bean class. A Spring component is actually nothing more than basically a regular Java class being managed by the container at runtime. So the container is responsible for creating it and for managing its lifecycle. And basically a large Spring application is just a set of managed components and their interdependencies and their runtime management that the framework provides for them and around them. But let's go back to the component itself. Fundamentally, we're talking about a piece of Java source code. So a regular Java class doing regular Java things like implementing Java interfaces and doing regular Java constructors and service methods. Let's assume that this update book method actually is also declared in the book admin service interface. Then add transactional can actually work with interface-based proxies. That's kind of the typical scenario. So add transactional already and annotation. What do those annotations actually tell us? Well, annotations are a Java language construct. They are a piece of metadata that you bake into your source code. The compiler actually understands those annotation types and their attributes. So it's a compiler-validated metadata added to your classes in the end. From a source code readability perspective, they are actually descriptive elements, if you think about it. This is a piece of Java source code that you might be writing, and the annotations add certain characteristics to your source code in the form of these type-safe pieces of metadata. So there's this service annotation, there's a lazy annotation, the auto-wide annotation, actually optional, we'll get to that, and the transaction annotation. Different pieces of metadata telling you about certain characteristics of this class. For a start, this is a service class. It's not just indicating the service-ness through its name, because that's not very type-safe, and who says that all the service classes have to be named service? Service is a role, a stereotype, like back in the good old UML days, a specific kind of class that you're declaring here. It's a service class, and the add_service annotation formally declares this class, this Java class, as having the role of a service class. Lazy is a initialization hint in Springland, basically telling the container you may create this whenever it's actually needed, not necessarily on startup. But from a readability perspective, you can even read it. And the type level annotations work like a sentence. The myBookAdmin service class is a lazy service class, or myBookAdmin service is a lazy service class. You need to jump around a little, but it's actually readable. And the choice of names here, the choice of annotation names, actually supports this readability perspective. That's why service is a noun. That's why lazy is actually a characteristic. And that's the reason why auto-wired is descriptively worded and not an instruction. These are descriptive elements, because at the constructor level, again, we have a regular Java constructor. It accepts a reference to another bean, a dependency, another bean that we want to delegate to. The typical way of indicating it is the Spring auto-wired annotation, because this constructor is auto-wired, to be auto-wired, meant for auto-wiring. Right? You can phrase it in different ways, but auto-wired is actually a description of the role, the purpose of this constructor. Just like public is a hint to the visibility, auto-wired is a hint to the runtime role of this constructor. And transactional works the same way. The update book method is transactional. This is a transactional method. So just try the readability against pieces of your source code with Spring annotations. It usually flows quite well. All right, so to wrap this up, why is auto-wired commented out? Any idea? Yes, indeed. I don't have a T-shirt, I'm sorry. It's not the keynote anymore, but that's all right. So just summarizing, rephrasing the answer, as of Spring 4.3, the auto-wired annotation is optional. You can declare it, but you don't have to if the arrangement is obvious anyway. And obvious to us, to the containers, means if there's only one constructor, it's not a default constructor, it accepts parameters, but there's only one of those, and the component is registered as a Spring Bean, then the framework just leniently makes an assumption that you probably want us to call this constructor with the provided dependencies as parameters, as arguments. So we imply the auto-wiredness as of 4.3. 4 classes with a single constructor that's designed for dependency injection. I actually recommend annotating it, in particular in this kind of context. When you have a class with type-level annotations and method-level annotations like @transactional, I would recommend adding auto-wired annotations to your injection points, even to the constructor, essentially for descriptiveness, for readability, not just for your own reading of the source code, but for somebody else reading this piece of source code. @auto-wired may provide a hint about the design of this class, of this constructor, that might otherwise not be obvious. The reason why it's optional is largely for classes with no annotations otherwise. Imagine a Java class, a delegate, a repository, a service class, which is being registered through add-bean methods or through add imports in configuration classes or through annotation config application colleagues.register, where you're enumerating the classes. And it doesn't have any annotations otherwise. No service annotation on top, no component annotations, no transactional annotations. And in those cases, it's actually nicer if the constructors can accept references without having to have an annotation on it. So we're doing it basically for a slightly different purpose. But simply speaking, as of for the 3, in a single constructor scenario, add auto-wide is optional. Right, a quick detour. Annotations in Springland are composable. And we take this pretty far. So I can only really dive into it a little bit here. Annotations are composable in the sense of you can choose to declare a custom annotation type, like a MyService annotation. An annotation is just a regular piece of Java source code. It's declared as an add interface, but as easy to declare as a regular Java class, really. Don't forget retention runtime. That's in Java's language design, unfortunately, not the default. So add retention runtime if you want the framework to see it at runtime. And then this custom annotation can serve as a holder for what we call meta annotations, annotations on top of an annotation type. So the MyService annotation itself has a couple of annotations on its own declaration. It says, I kind of inherit the characteristics of an add service. I change the default scope to session because the scope is singleton by default, right? So for any use of myself, the suggested default scope is session. Good point. As of for the 3, there's an add session scope annotation, which you could be using here. I admit that slide predates for the 3. But in the end, it doesn't matter as much here because you're composing a custom annotation type and the end result is type safe anyway. So you by default, you basically get raw proxying. You would typically set a proxy mode here, so point taken. You may bake this in. This is actually a reason to design a custom annotation. You may suggest a proxy mode. We actually get to that in just a bit. On the next slide. I'm going to talk about custom proxying and custom scoping annotations. So a custom annotation is basically a composition of several other annotations declared as meta annotations on top. The simple idea is whenever you declare your custom annotation, like add MyService on any number of your Java classes, you actually mean the combination of characteristics above. You imply the combination of characteristics above. So whenever you say add MyService, the container basically sees the meta annotation and behaves just like if you declared add service, scope session, primary, and even the default transactional rule. There is a strong design element in here, because it's your choice to declare a custom annotation to begin with. You choose its name. You may choose its name at least, right? I mean, here it's MyService. I intentionally use dump class and method names here because I don't want you to actually use the same names in your code. Choose a name that has a meaning in your code base, a name that has a meaning in your application architecture, like account service, order service, named after some vertical or horizontal slice of your code base, a name that has a meaning in your code base. And whenever you attach that custom annotation, it's actually quite readable then. Like this, my book admin service is a my service, right? I mean, is an order service, is an account service, is whatever you named it. So custom annotations have a naming quality to it. So we actually have a custom scoping annotation here. As of for the 3 to pick up on the previous note, we actually ship out of the box session scope, request scope, and application scope annotations. They are declared exactly like this. They are just conveniences because you can do this on your own. And there may be reasons why you do it. For example, choosing a different proxy mode by default. This annotation is actually an interesting piece because of the attribute override. So this is a custom scoping annotation, because you can use custom annotations everywhere. You can build custom injection annotations, custom mapping annotations, even custom add-bean annotations if you insist. But in particular, custom scoping annotations. And this custom annotation says, I'm named my session scoped, I'm meta-annotated with add scope session, basically. I'm baking the session key into my declaration, hardwired. No, nobody can change it, nobody can have a typo in it, so it's type safe in the sense of the session string being hard-coded and part of the my session scope type name. And this custom annotation chooses to redeclare an attribute. This is a general mechanism, works across all the Spring annotation, within the entire Spring annotation universe. It chooses to declare a mode attribute of type scoped proxy mode. And there's an alias here. The alias for annotation says, this attribute is basically points to the standard Spring scope annotation, annotation equals scope class, and to the proxy mode attribute there. So it basically is an explicit reference to the attribute that it is overriding. Whenever you use add my session scoped, you can say mode equals whatever, right? And it has the same effect as if you set the proxy mode attribute on add scope. There's the explicitness of the alias for is really nice here because it's quite readable. I mean, you can find out what the intent of this attribute declaration is. And you can choose to rename the attribute because a little nuance here, the mode attribute chooses to have a shorter name than the original proxy mode attribute on add scope. This is also something you can do with the alias mechanism. And there's a default attached. It says default scoped proxy mode no. This is standard Java annotation semantics in the Java language. You can choose to declare a default. In this case, it's no, which means raw proxying, but in practice, you might want to choose scoped proxy mode target class, for example, or scoped proxy mode interfaces, and bake it right into your custom annotation. The my transactional annotation at the bottom is kind of another variant of it. It's basically doing the same thing. It's a custom transaction annotation, meta-annotated with add transactional. It has an alias declaration, all good, basically, all the same kind of idea. But it chooses to not declare a default. Right? It says Boolean read-only, no default. According to the Java language rules, this means that any user of add-my-transactional needs to explicitly say read-only equals true or read-only equals false. You're basically forcing the user of your custom annotation to set a value for this particular attribute. This is a feature. You can choose to do this. If you want to guide the users of your annotations towards reasoning about specific attributes, because you find them particularly important, just don't declare a default. With add transactional read-only, that's actually kind of a good idea because it's easy to forget to provide the read-only hint. And with this custom annotation, you're forcing everybody, basically, you're saying, these are our annotations, use them, and when you use them, these are specific attributes that I want you to make a decision about. Explicitly reason about your transaction scope and explicitly say read-only true or false here, please. This is what this annotation declaration implies. So there may be many reasons why you build custom annotations. It may be a stereotype, it may be a scoping annotation, it may be a custom transaction annotation or anything else. Let's move on to the configuration classes and have kind of another look at what configuration classes provide to us. There's a couple of subtleties in here that may not be obvious, even if you've been using configuration classes quite a bit already. Configuration classes are regular Java classes, kind of, right? They are definitely Spring-managed component classes. They serve a specific purpose. They are there to declare add-bean methods. So the special feature of configuration classes is that they have a special role in your container at runtime. They are Spring-managed beans declaring other Spring-managed beans to the container. Every add-bean method is being turned into a bean definition at runtime. So the container introspects those methods and adds another bean definition for every add-bean method found here on a configuration class. simply speaking. There is a bean definition for the configuration class itself as well. The configuration class itself is also a Spring managed bean and has state. It can have fields, can have instance state. Add configuration is the special stereotype attached here, right? So the add configuration on top here is just a Spring stereotype like add service or add controller or add repository. This one says add configuration, and the container makes some assumptions about those classes because of that stereotype. Whenever you say add configuration, you mean a specific role of this class and specific container behavior to be attached to the add bean methods on this class. And some of the specific behavior is hinted at here. Our myBookAdmin service factory method actually has a setDataSource call pointing to another admin method within the same class. It says bookadmin data source, looks like a regular method call, pointing to that other method down below. This is part of the special behavior here, a special runtime behavior here, because the container is going to intercept that call at runtime and going to interpret it as a kind of symbolic reference. You're not actually calling this method. You're pointing to that other bean definition derived from that method. So you kind of go back to the container. The container is looking for an existing instance of bookadmin data source. It might just pass the existing instance back to you. Or if no instance exists yet, it may choose to call the factory method in order to create a fresh instance of that bean. For a singleton bean, that's only going to happen once, and then the instance is going to be reused. For a session-scoped bean, this may actually happen dynamically based on the use of those beans in a new session. So there's special behavior attached to this, and the way that we are providing this at runtime is simply through cglib subclassing. So some basically bytecode magic. We are creating a runtime subclass of a configuration class, and we're going to override all the addbean methods. So whenever we get an invocation to this method, we're going to pass it back to the container and leave the decision, the lifecycle management decision, up to the container. Whether it needs to create a new instance, whether it needs to create a proxy for that instance, all of this goes the usual way through the container. This is behavior attached to add configuration classes. If you choose to have simpler addbean methods without calls in between addbean methods, just simply structured factory methods that do their job in isolation, you may choose to declare addbean methods on other component classes. Just do not declare the configuration stereotype, and cglib goes away. No runtime subclassing, no interception of those method calls between addbean methods anymore. This is attached to the configuration stereotype. Addbean methods work on other classes as well. Then they are just regular factory methods with the container deriving a bean definition from them. And as we've seen before, you may declare them as static, which means they can be called without creating their containing configuration class. This is part of the design here. The configuration class itself and its state is important to have for the factory methods to work. A non-static factory method can only work if its containing configuration class has been created. Along those lines, a configuration class may choose to do regular Java things like declaring a constructor. Admittedly, only as of further 3. In previous versions of Spring, you would have had issues here because the cglib generated subclass only had a default constructor. So in practice, you couldn't use overloaded constructors or even non-default constructors in general. As of further 3, we relaxed that and we are a little more sophisticated in what we create at runtime in the cglib subclass. So from a user model perspective, you can just declare a constructor, for example, accepting a reference to another bean. A configuration class is a regular Spring managed bean. It can accept references to other beans. In this case, we accept the data source at the constructor level, store it in a field. Configuration class is a managed instance, has instance state, right? So we keep storing it in the data source. Whenever the factory method is invoked, the setDataSource call below here just takes the field and passes it into the setDataSource method of its target class, of its target instance. So instead of calling to some other addbean method, we obtain references through dependency injection and bake them into the objects that we return from our factory methods here. That's entirely valid and part of the core design behind configuration classes. And it's more obvious now why the containing configuration class has to be created first, right? Created, constructed, instance fields populated, and only then such factory methods can actually do their job at runtime. Declaring them as static makes it impossible to refer to the fields, just like in regular Java, right? So think about the state in your Spring Managed components. Think about the state in your configuration classes as well. Now, why is add auto wide optional anymore? Let's shortcut it. Same reason as before. As of for the 3, in a single constructor scenario, we are going to call the single constructor even if it has arguments, assuming that it's meant for dependency injection purposes. Right. So to wrap up the configuration class part of this story, regular Java classes can use inheritance. What if configuration classes choose to extend from some other class? Usually some other configuration class or configuration fragment. Well, it works as you would expect it to work. Our design philosophy here is you're doing regular Java things. We encounter them at runtime when you register those classes with our container. So we try to apply reasonable behavior along the lines of the Java language rules, the Java language specification. So in the Java language, inheritance means that methods are being inherited, can be overridden in subclasses. You can choose to do this. We follow the same rules. So if there is an admin method in the base class, we detect it and register it. If you choose to override it in your subclass, you choose to override specific admin methods, we take the overridden method and the metadata from the overridden method as we should. If you extend an abstract base class, and the abstract base class has a couple of abstract admin methods, that's a fine design concept. You're basically providing a configuration fragment, we're calling that a fragment, a configuration fragment, and a concrete subclass can choose to extend from that fragment and to kind of complete the configuration arrangement through implementing the abstract admin methods. Provide a few remaining beans and all is complete, all is good. So this is not something special that we kind of invented in our configuration class model. It's actually just regular Java language rules applied. Now, along the same lines, a little more fancy, in Java 8, what if a configuration class implements an interface and that interface happens to declare admin methods as Java 8 default methods? Now, let's ignore for a moment whether that's a good idea. Let's just assume somebody did this in the code provided to the container. The behavior is still the same. We detect the admin methods in the interfaces. We actually have to explicitly detect this. Default methods are a strange beast in Java reflection. We detect them and we apply the same overriding rules. You may choose to declare them in your configuration class hierarchy. They override the default methods then. If you don't override them, if you don't substitute them, then we are going to use the implementation declared in the interface method body. Of course, a Java 8 default method follows specific rules in the interface. You can't access any state. Interfaces don't have state, so it needs to be a kind of self-contained method. You can point to other methods declared in the interface, though. And the other methods can be regular interface methods, like abstract methods in a class hierarchy. So you can provide configuration fragments, as of Java 8. You can provide a configuration fragment as an interface with some admin methods declared, pointing to other abstract interface methods in the same interface. And the concrete configuration class then implementing one or more of those configuration fragments and kind of bringing them together in a concrete piece of configuration. The one or more part is the actual feature here. You can choose to implement more than one interface, kind of multiple inheritance of admin methods. Of course, not multiple inheritance of state, because it comes from a Java 8 interface, right? We are following Java 8 language rules. If you're wondering about the nuances of those semantics, basically read up on Java 8 default methods. The same rules apply here. The only thing we're doing here is we accept what you provide us within this Java class. We don't actively recommend this, but there may be some use of this in a configuration fragment scenario. Maybe it's useful for some architectures where a lot of configuration fragments are provided by distinct teams and then kind of assembled by another team. We leave this up to you guys, to the application development teams. We're just applying Java language semantics consistently here. Going the extra mile, even where we need to do extra steps to make those semantics work at runtime. Now, switching the focus again to something we've had in the keynote as well, injection matching. Just in all applicable brevity, a couple of key points that are sort of new or sort of nuanced enough to require maybe a dedicated hint. So let's assume there's a class with an auto-wired constructor. And this constructor accepts a myRepository of account. So that suggests that the myRepository type has a type variable, and we're substituting the type variable with account here. All good and actually quite common, in particular for repositories. This could be a Spring Data repository, but doesn't have to be. It could be a custom repository interface or a class. Now, in another part of your code base, usually, not in the same classes, but in some configuration class somewhere in your code base, you would have some admin methods. And let's again assume that we have two admin methods, my account repository, my product repository, and they declare a myRepository of account and of product in their return type. This is actually significant. Pay attention to the admin return type declaration. Because the matching algorithm is going to take the injection point declared type here, myRepository of account. It's going to try to find corresponding assignable bean instances among the other bean definitions, in this application context. So it's going to look at the bean definitions derived from those admin methods. It's going to find out that myRepository of account is a match, but myRepository of product isn't. Standard Java language rules in terms of generic type handling, in terms of type variable handling. This is actually the simplest possible case. I recommend to keep it simple. If you can, keep it as simple as it is here. But in practice at runtime, it's actually an assignability rule. So even if you return a myRepository impl of account up there, and it happens to implement myRepository of account, it's still going to work. It's an assignability check. It's not a key, it's an assignability rules, the same assignability rules as in a Java language assignment. So as a simple mental model, imagine you declare a variable in your piece of Java source code. You say myRepository of account on the left-hand side, and you're trying to assign a new myRepository impl of account on the right-hand side. If the compiler is going to accept the assignment, we consider it a match. That's the simple rule behind this. This is actually somewhat new. As of Spring Framework 4.0, it works like this. Previously, we just looked at the primary type declaration, so we didn't take the account or product part, the type variables, into account at all. As of 4.0, we take the generic type declaration into account, fully into account. There could be any nested type arrangement here, any number of type variables involved. It's actually a pretty complex beast, generic types, right? But if you keep it simple, it can be super useful, as indicated here. I would recommend doing this over qualifiers. If you find yourselves in the need of declaring qualifier annotations, basically think again, revisit that piece of source code. Could you somehow make the type declaration more unique so that the type declaration itself already indicates a specific target bean without any extra qualifier metadata? If you can, do it. In some cases, it may even make sense to introduce a type variable just for the purpose of type matching. And always make sure that the return type declaration of your admin method is as specific as you could possibly be, because the container is going to look at this return type signature before it actually calls the factory method. You're basically providing a type hint to the container in a static form. The container understands the type of your instance before it even calls the factory method. That's a good thing, in particular if you declare too many post processes, or if any kind of early startup early startup processes involved. It's a good idea to be as specific as you can in your static declarations. All right. So just as a variant thereof, what happens if you ask for a list of myRepository of account, like a collection type with a nested generic type? Works as expected. Just say list of myRepository of account. We're going to select the My Repositories of account, just the ones of account, just the assignable ones. We're going to build a list from them. We're even going to order them to sort the list for you if you provide order values with the admin methods. The orders are relative, so just within any kind of dependency set. This is just a relative ordering hint within the outcome of such an injection attempt. Then we inject this list into your constructor. Now, we've had a variant of this discussed this morning. What if you declare a list of accounts in the injection point and not several account beans, but rather a single bean, which is declared as list of account in its return type signature in an admin method in this case? It does the obvious, it just works, right? It will consider this a match as well. We consider both scenarios as valid as of for 3. But be aware that you're dealing with a generic type arrangement here. You need to provide this generic type information in a way where it's retained at runtime. In Java, even if we talk about erasure with generic types, erasure is just an instance problem, right? If you have an instance of a list, the list doesn't know what it's been declared with. But if you have a signature, like a field signature, a constructor signature, a method signature, the method signature may contain a specifically typed list as a return type here, for example. And we just obtain this information via runtime reflection and will consider this a match as intended. If you have a single list, you won't notice the difference, but try declaring several beans, all of which are a list of something. Then you will benefit from this assignment rule where we actually understand the nested generic type there in the admin methods. And again, be as specific as you can. You may choose to declare an array list of account up there. It's an assignability rule, will still work. But be as specific as you can. In particular, declare the element type if you can. All right, laziness, my favorite feature today. So laziness actually has 2 distinct meanings in the Spring Component model. You may choose to declare lazy on a bean definition, or basically at the declaration point. So the add_bean method, if the add_bean method says, my bean definition is lazy, right? Or if your service class, like on my initial example, if the service class says, I'm at lazy, this is a life cycle hint to the container whenever it chooses to declare, chooses to create an instance of this bean, right? It basically makes an assumption that it should do it as late as possible. If it's a singleton scope, this has the effect is strongest with the singleton scope, where a singleton by default is created eagerly. Basically on startup, all the singletons are being created. So if you add lazy, it basically means we're going to defer the initialization to the point where the bean is actually being used, where it's actually being obtained by somebody else. So if you've got other beans created expressing a dependency on this bean, it won't make much difference because we're going to create it whenever we resolve that dependency. So we defer the decision to the point where some other dependency requires access to this bean, declares access to this bean. Now let's switch our perspective to the injection point. This is again a constructor. It says I want a my repository of account, but it adds a lazy annotation to the parameter here. It's actually a parameter level because there could be several parameters, right? A constructor can take several references to other beans. Each of those references can individually be declared as lazy or not lazy. So what does lazy mean here? Lazy is a pretty important hint. It actually indicates that my bookadmin service is not going to use this reference right now, not immediately. My bookadmin service basically says, give me a my repository of account, but I'm okay if it's not fully initialized yet. I don't insist on it being fully initialized because I'm just going to store the reference probably in a field and I'm going to use it sometime later whenever service calls come in, whenever some concrete stuff is going to be processed in my business logic. This is a pretty important hint because if you do not declare it as lazy, the standard rules, the default rules are, my bookadmin service insists on a fully initialized my repository of account bean at construction time. This is a pretty hard requirement. Relaxing this requirement makes a lot of things work, in particular in the startup lifecycle. So consider declaring at lazy. This is actually pretty common, right? There are many constructors that just store the references in a field. Circular references, for example, are only an issue if both ends of the circle insist on a fully initialized other. Only then a circular reference cannot really be cleanly resolved. If both of them say, I want a lazy reference to the other, a circular reference is not an issue. That said, don't use circular references. Model your components in a way where you don't even have circles. But just saying, in case you end up with a circular situation, add lazy can be a solution to cleanly resolve a circular reference arrangement. All right, so far from my lazy pitch. Sure.
A quick question. Can we use lazy annotation at the level of method, like authority, to apply to all parameters?
You can put it at the field or method level as well, but I strongly suggest to actually put it at the parameter level because that's where its meaning applies. It's not about, lazy at the method level would suggest that you're lazily calling that method. That's not true. We're eagerly calling the method, but we're providing lazy parameters, lazy references as parameters, right? So we're pretty strict about the semantics of those things. That's why it's parameter level. Parameter annotations are a fine thing. Standard Java stuff, just a little unusual. How does it work? The comment gives it away. There's an inline comment. Yep, it's a lazy initializing proxy. So we're going to create a proxy for you, an interface-based proxy if the declared reference is an interface, or an ACGLib proxy if the declared type is a class. So it only works if the declared type allows for proxying. That's true. Another variant of this is actually shown here. While we're at it, actually a perfect question. Look at this variant. The constructor says, give me a provider of my repository of account. Provider actually is the javax.inject.provider here. That's another way of getting a lazy handle, but it's not a proxy. In this case, it's a provider wrapper with a get method. So you're basically getting something that you can call get on. And later on, whenever you're using the object, you take the provider, call get, and do your call. Right, so that's another way of expressing the reference, and there's no proxying involved. That's also laziness, and that's even kind of a standard way to achieve laziness in GSR 330, in the dependency injection for Java standard in the JavaX inject package. So this is basically a Spring-managed class, works out of the box in Spring, no special things to do to make it work, but it uses standard annotations. So I've actually opted for all standard annotations here, so it even uses at inject instead of at autowired, and it uses the standard managed bean stereotype. None of these things can be composed, right? They are not as sophisticated as the Spring equivalents, but they do the job and we understand them out of the box. Some of your objects may choose to declare standard annotations, some others may choose to use Spring annotations. You may even mix and match within the same class. You could declare at autowired on this constructor, but use the provider type and use an at service annotation on top and use predestroy below. It all works, right? So it's a natural mixing and matching. Different annotations coming out of the JavaX inject package or coming out of Spring packages are just different pieces of metadata. The container naturally reacts to that metadata at runtime out of the box. And provider is actually a nice mechanism. We have a sophisticated variant called object provider, object factory object provider in Spring as well, a Spring specific type, being a bit more fancy, but lazy resolution of target instances through a provider or object provider can be a really good idea, just like at lazy on the previous example, in particular for constructors. So along the same lines, you might be aware that this is working. What if you declare a Java util optional type, the Java 8 optional type, in a parameter signature, in a dependency injection point? It just works. So if your constructor says, optional of my repository of account, the framework basically says, okay, I know what Java util optional means, right? So I'm looking for my repository of account. I'm going to find the bean for you. If I found it, you're going to get a Java util optional handle with that reference inside, injected into the constructor. If I could not find it, I'm going to pass optional empty in. And your constructor can then use the Java util optional API, the methods on Java util optional, to react to the presence or non-presence of that bean, maybe using a default bean, a default instance instead. This is a syntactic variant, but there's optionality implied. It's not just passing an optional object in. It's also understanding the optionality, because by default, if you declare a regular bean definition, a regular injection point declaration, we insist on that target bean being resolvable. You're going to get an exception otherwise. You can say at autowired required false, or you can say Java util optional per parameter. Both of them imply optionality. The container is going to say, it's okay, I couldn't find it, but you asked me to pass in. You basically said you don't have to have it, so I'm going to pass either null in the auto-wired required false case, or optional empty in if you declare Java util optional. Right, so to wrap it up, I'm not going to leave you without showing the endpoint design quickly. And the endpoint design, let's start with the best known one, it's Spring MVC. We're not going into details of this. We're just going to extend our story a little bit, because those endpoint classes, controller classes, are just regular Java classes with annotations inside. At runtime, they are Spring managed beans. They can have instance state, constructors, all the things regular Spring component classes can do. They have a special stereotype on top. They indicate that they are controller classes, not service classes, not repository classes, not configuration classes. They are controller classes. They use the same stereotyping model. And controller classes have a special feature. They can have handler methods with mapping annotations, just like configuration classes can have admin methods with special processing. So controllers can have request mapping annotations in this case, and handler methods to process the incoming requests. There's a general design principle here. Incoming requests or messages, right? An incoming HTTP request in this case is being mapped to a particular handler method through the mapping metadata provided here in the request mapping annotations. And then we're going to resolve the parameter signature. So the parameters are significant. We're going to look at the path variable, long ID part, for example, going to resolve it for you. There's parameter annotations again, because there can be several parameters, right? You can have several path variables, or a path variable and a request header next to each other. So we understand what path variable means. The default name is the parameter name. We resolve the path variable from the path, convert it to a long for you, because that's what you declared. And then we're going to invoke the handler method that way. This design principle, I assume you know it from Spring MVC here, is actually consistently applied in all the endpoint models in the Spring ecosystem. But there's even a little twist here. Actually, this is kind of what we've seen before is kind of the standard way of doing things. As of Spring 4.3, we provide convenient mapping annotations called get mapping, post mapping, put mapping, and so forth, that are basically just composed annotations along the lines of what we've been discussing before. Pre-composed annotations, but pretty convenient. They are making use of an annotation language feature. If you only provide one attribute for an annotation, you don't have to specify its name. You don't have to say path equals books ID. There can be a default attribute named value. We're making use of this here. So get mapping implies the HTTP get from its type name, from its annotation type name, and usually only takes the path as an argument, which is a really nice, concise way of doing things. Of course, that's not really too surprising. You could have composed those yourself easily. The annotation composition model in Spring naturally allows for doing these things. As of 4.3, we just ship get mapping, post mapping, and co out of the box. That's the only difference. Meta annotated with request mapping. All right, but to complete the storyline, endpoints are diverse in Spring. We have many endpoint variants in the meantime in the Spring ecosystem. For example, even in Spring Framework itself, there's support for stomp message processing, stomp message endpoints on a WebSocket channel. Let's not dive into what this does at runtime. Just look at it stylistically, syntactically. The endpoint is a controller class, handler methods, flexible parameter signatures, and mapping annotations to indicate which handler method to bind to which kind of incoming message. And in Stomp land, messages work within a kind of path structure, and there are two types of interaction: regular payload messages, message mapping down here, or subscribe requests, subscribe messages, the subscribe mapping above. So we are using the same design principle. We're modeling something different. Stomp messages on a WebSocket channel. But it looks like and feels like a Spring MVC REST controller. All right, and along the same lines, you'll find some consistency in the design even for GMS endpoints, for the simply structured GMS endpoints or the one with a ton of metadata that GMS usually needs to do its job properly. Same design idea. Method level processing callbacks, annotations kind of attaching a listener to a particular method. And if you look at the method below, nested annotations like @header pointing to resolve, in this case, a GMS header, but the same kind of design idea. Flexible parameter signatures and parameter annotations to indicate how you would like to resolve this particular parameter. And last but not least, this is actually the last slide, last but not least, if you're processing application events in Spring, as of Folder 2, there's a similarly designed model. This is actually application events within an application context. So it's not really an endpoint, but the design is nevertheless quite consistent. It's an event listener model. A particular method is being called if a corresponding event gets published. You may accept the event as a parameter. You may even declare the payload of the parameter instead, and we're going to auto-extract it for you. And you can attach conditions. So it's a little bit like a mapping, but it's not quite a mapping. That's why we call it a listener. But there's a design consistency between all of those method level endpoints. And the examples I've been showing just show the Spring Framework itself. You'll find the same design consistency in Spring AMQP, in Spring integration, in other projects in the Spring portfolio. All right, that's the end of my little storyline, the end of my tour through the Spring component model. I hope there's been some interesting insight here or there for all of you. Even if you've been using Spring for many years, I'm pretty sure there might have been some nuances that you were not aware of at all. Well, thanks for your attention. I have a second presentation this afternoon. It's actually on a very different note. It's about Spring Framework 5 and discussing the Spring Framework 5 plan and feature themes and the roadmap. So it's a forward-looking presentation towards the next generation of Spring. That's, I think, 3 o'clock this afternoon. So thanks for your attention. Enjoy the rest of the show. If there are any questions, just come up to the stage. I'm happy to discuss them with you.